Ship2Shore with the Northeast Pacific Deep Sea Exploration Project, or NEPDEP. So thank you very much for joining us, everyone. We are really excited to be here and to connect with everybody. And you know what? It's great that we got all those wrinkles out first, because now we can just go ahead and have a great time. So I am your host today, Monica Peltz. I'm an education coordinator with Ocean Networks Canada. And unfortunately, I don't have my colleague here with me today, Nick, but we are excited, of course, to welcome everyone. And we do like to start with the territorial acknowledgement. I am doing the one that is reflective of where I am in Victoria. And I know that you probably have done one as well for there in Vancouver. Would you like me to start, or would you like to do yours first?
I already did ours, so yeah,
Wonderful.
go ahead. Thank
In
you.
that case, let me just say, we acknowledge and respect the Lekwungen peoples on whose traditional territory the university stands, the Songhees, the Esquimalt, and Wasanich peoples whose historical relationships with the land continue to this day. We acknowledge the Indigenous communities with whom we honor to collaborate, whom we have the honor to collaborate on coastal monitoring and data management solutions. So again, recognizing that I am from a settler family on these lands, and that we have to do this in partnership, and recognizing that the ocean has had stewards from time immemorial, and we respect and acknowledge them. So just a little background about Ocean Networks Canada, one of the partners, and again, I'll keep it short and sweet, but we are posting data online that anyone can access. We've got all sorts of data sources all over. And so again, that ship out at sea that is contributing to these data sources. Ocean Networks brings in about 1 terabyte of data a day, which anyone can access. And of course, that is complemented by these at-sea expeditions. And it's where you can find live streams. So of course, they've been out at sea streaming all this time. And if you've missed some of them and you want to go back and see more, those are hosted on the Ocean Networks Canada network for free. And you're welcome to visit and check those out. And of course, we would like to thank all of our partners. This is a huge collaboration with the Haida Nation, University of Victoria, Ocean Networks Canada, Royal BC Museum, Fisheries and Oceans, as well as being part of the UN Decade for Ocean Science and the Challenger 150, and many others as well. Just a quick recap. We know that the group is going to be they were at sea from August 13th to September 2nd. So we know that this is the last of it. They're ready to come to shore, I think. But it was a huge collaborative partnership exploring the Haida Gwaii marine protected areas. They were aiming to discover, explore, and monitor deep sea ecosystems, which I'm really excited to ask them about. And of course, we're going to learn more about Ropos. I've heard from the ship that he's on board right now. And so we'll have a chance to connect with them and see what Ropos looks like. And again, we did want to mention that all of this is archived. It's on the internet these days, so you can head over to NEPDEP.com or the NEPDEP Facebook page to see more, connect with more, and look at some of those great historical videos as well. I know that the Skates video is up there, which is a great place to check it out as well. So that is a fantastic one. Here, of course, is the expedition area where they've been exploring. So marine protected areas, proposed marine protected areas, as well as national marine conservation areas. So they've had a chance to go all over and see some really neat things there. And then, of course, they're on the John P. Tully, which is a fantastic vessel. And I think we could jump over and join them right away. Just who are we going to be joining? We're going to be joining these lovely folks. We have Cherise Dupreez. There they are. There's Cherise. We have Heidi Gardner. That's Heidi. She's out at sea, and she's on our deck, which it looks like a beautiful day out there, Heidi. Wonderful. The lovely Rain. How are you, Rain? Looking good. And will Aiden be joining us today? Nope, he's busy. That's okay. This is the great thing about marine science, is there's always something going on. And so we have all these people lined up because we never know who's going to be busy, who's going to be holding samples, who's going to be back and forth. It's great. Alrighty. And last but not least, if folks would like to ask questions, there's a couple of ways to do it. I hear we've got someone monitoring the YouTube chat, but as well, we have Menti. And Menti is awesome. You just go to menti.com. You don't have to sign in. You don't have to do anything fancy. You just throw in this code 3551 3719, and I'll read those questions and I can relay them to the ship. So I know in person you've got some great ways to ask questions. I think people can put their hands up and they can communicate with you, but we also know that we've got an online audience, and man, it'd be a heck of a commute over to Science World this morning. So what we're going to have them do is use this Menti. So again, you just go to menti.com, throw in that code 3551 3719. I'll get all those questions and I will relay them to the ship as well. So please don't be shy. There's lots of ways to ask questions. But really, you didn't come to hear from me. You came to hear from them. So I'm going to stop talking.
Thank you. Maybe it's our turn. Can you hear me okay?
Yep,
okay.
we can hear
Hi,
you.
Monica. Hi, Science World. Hi, everyone in the audience there. Thank you for joining us today. My name is Dr. Charisse Dupree, and I am the head of the Deep Sea Ecology Program for the Government of Canada, and I have had the absolute pleasure to be the lead scientist of this amazing expedition. And beside me, I have friend and colleague Rain. Do you want to say hi?
Yeah, hello everybody. Thank you for joining today and making the trek to Science World to listen into our incredible expedition outcomes. My name's Rain Boyko, and I'm here on behalf of the Council of the Haida Nation.
Rain, do you want to jump right into this?
Sure, yeah. Yeah, so we have been on the Canadian Coast Guard ship, the John P. Tully, and it's been about, how long has the journey been since start to finish? 3 weeks. I've been on board for about 2 of those weeks. We are just coming into Victoria shortly, sometime this afternoon, so coming to a close now, but it's been a really, really incredible expedition. And this is our robot, our remotely operated vehicle, ROPO. So this is the ROV that we deploy and send to the deep ocean to capture all of that beautiful imagery that we get to see. Yeah, and the first stop was in the Hecate Strait sponge reef. And so this is an example of what was seen in the depths there. Yes, and unfortunately, we also come across some fishing impacts, which can look like this marine debris. This is a large trawling net that was disposed of in the deep, and unfortunately, these this marine gear can sort of carry on damaging the deep ecosystem for many, many years, as it takes time to break down, and it can kind of continue in that cycle of wiping out those sponges and corals. So. Yeah, so this is an underwater river area, and you can see here there's a bit of the sort of erosion happening underwater, and that tells us it indicates some signs of certain current flow, which we call underwater rivers.
And this is a proposed place.
Yes, this is a proposed place for protection.
Yes.
Yeah, and so here we're in a beautiful coral garden and sponge garden, and you can see lots of different kinds of rockfish and deep sea creatures living down here. This was on Kintless Bowie Seamount, just on the northwest coast of Haida.
I just want to add that these corals, they might look small here, but they're meters tall. And at meters tall, they're hundreds to thousands of years old. And even the rockfish that are living in between them can be up to 200 years old. So a really neat deep sea ecosystem with big animals, long-lived animals. Okay.
Yes.
Moving on to
Yes, the Tuzo Wilson or NEPDEP 58 and 57 seamounts. And this is south of Haida and a really, really special place that we hope to protect in the near future. And I'll hand it over to Charisse to give you some more details about that.
Thank you, Rain. Yeah, so this is probably the star of the show if you had to choose one from our expedition. It is an actively venting underwater volcano that until recent, we didn't even know the volcano was there, let alone active. And when we went to the summit of it, we see that a lot of it is made out of this lava. But then we started to see these strange shaped rocks. And on closer investigation, we found out they're not rocks, they're eggs. They're giant eggs being laid by this massive deep sea animal that's coming up from the abyss onto the top of the summit of the volcano where the warm water is coming out, and it's laying its eggs. Now, this has been seen one other place in the world. About 5-6 years ago in the Galapagos, they found a nest of 150 of these eggs. We've found somewhere upwards of 1 to 5 million of these eggs on top of the volcano. That's a lot of energy being put there. It's a migration route that these deep sea animals are really relying on for the health of their species. So let's flick through some pictures here. So this is one of those animals. It's a giant Pacific white skate. It's a close relative of the shark. And in the picture here, you see it's actually diving down. Here's the lava of the volcano. Here's some of those corals we were talking about. It dives down and it scratches against the coral on its underside to help it lay its eggs. And so here's another one that's sitting down in a position that tells us it's laying its eggs. We have an egg underneath one of its pectoral fins here, and actually right below it, where the rock is a bit yellow, shows us that that is a site where the venting is actually coming up. So we're hypothesizing, we're coming up with guesses and testing them. But what we think is happening here is the skates know that if they go to this volcano and they lay their eggs, those eggs will be warm, they'll be sheltered by the corals. When they hatch, the animals will have food to eat. And it's really important, if you're a deep sea skate, to choose the best place to put your eggs, because you may only lay like 2 to 4 at a time, and you have to leave them there for 4 years. So you want to choose a really good site because it takes 4 years for those eggs to hatch. And we think this place is a pretty good site. So here's us using a temperature probe to measure all the warm water coming out of this volcano. And then I'm going to jump to some other really neat things we saw, because we spent some time at Tuzo-Wilson, but we went to the other places, and we spent a lot of time in the water column too. So here we have another awesome mom of the deep. It's a squid, and those are thousands of eggs she's carrying in the water column. Some other neat rare sites. We're about of the 100 people on this planet that have come face to face with the giant phantom jelly. So it's a very rare sighting. We got to spend about half an hour with this jelly. If you look at this and you're thinking Harry Potter, we did too. It looks very much like a Dementor. Then this is a crowd favorite. This is the blobfish. And the blobfish is an adorable little fish that lives on the seafloor. And for the first time this time, we found its nest. So it lays pink eggs, which was really exciting to everyone because, of course, if you're a cute blobfish, why wouldn't your eggs be pink? That is so adorable. Another awesome mom that we found in the deep is the deep sea octopus. We see her sitting here along a rock. There's her arms, and those are actually tiny eggs, the white there. And we could look into the eggs just with our cameras and see the 2 eyes of the baby octopus. And she is actually the record keeper in the world. She holds the record as the longest time sitting on her eggs. She clocks in at somewhere between 4.5 to 7 years of care, not eating, not moving. Wins mom of the deep for sure. And then just some other things. We are floating out in the middle of nowhere. So our neighbors that pass by every now and again include things like the giant fin whale, the second largest whale in the world. And while it's amazing to see them and on the surface, when we're in the deep, we actually see signs of them too. And we call them whale falls. And it's when the natural process of death happens in the ocean and the whale bodies sink to the seafloor and they leave their bones behind, but for some time they would have been an absolute buffet for animals of the deep to thrive, eat, live. And then here's another neat picture of a passerby that dropped by the boat. It's a salmon shark, and it's on its way to Japan. It's got a long migration ahead of it. It came across this log, and it's giving itself a good old scratch on its belly by jumping up onto the log and kind of skateboarding along it. So that's always a fun one to see. And in addition to taking lots of video, we also collect specimens. We photograph it. We share it with museums. We take cores down and we stick it in the ground to collect specimens, to collect the mud, to study carbon in the deep. We also collect a lot of water, so we send down a rosette. And Heidi will show you a little bit more about this, I think, on the deck of the ship. But the rosette goes down and it's open bottles. And when it gets to a particular depth, we trigger the clicker and it closes the bottle and it brings that water column little sample up to the surface for us to test. And it might be a little bit small for you to see, but we also cast small nests over the side of the boat to study what lives in the water column. And for the first time this year, too, we also deployed cameras that hung out in the surface waters with a little bit of base on it so we could see what animals swim around these very deep sea things. And we call them BRUVs, baited, remotely operated cameras. And it was a very neat success that we tried for the first time. Even though we've been doing this program for 7 years, we're still testing new equipment, and that worked very well. Found out there's a lot of sharks out here. So this is us deploying the BRUV. We leave it soaking for 12 hours, and then we come back and pick it up. And I think this is one of the last pieces of equipment. This is a glider. We send it off into the ocean. We say goodbye for a couple months. It goes up and down, and it talks to satellites, and then we pick it up, and it collects all kinds of data. So it doesn't need to stay with the ship. It's like, we say goodbye, come back and give us data, and then we go fetch it, and now it's got all that data on it. We streamed everything we did live to a global audience. And like Monica said, that's all online. And we were all over social media. So if there's anything you want to follow up on more, you can take a look. Here's us doing some live events. That's Aiden, who's missing in action right now, but was with us for a lot of this trip. And yeah, like Monica said, we've actually come to the end of the trip, which is a little bittersweet, but we have some amazing stories to share with everyone because we've been out here so long. So we look forward to your questions. And I'm going to say this might be a really good time to either answer some questions or send it out to Heidi. So I'll let the host decide which ones they want to do.
Why don't we see if we have any questions? And if not, we'll send it out. Yeah. Do we have any questions from the audience?
Well, while you're waiting for questions there, I'm going to ask Charisse a question. Now, Charisse, why is it called NEPDEP? Why is it called NEPDEP? And you talked about that 7 years of data. Maybe we could do a little plug about why we picked that. I mean, of all the names for an expedition, why that one?
Yeah. Okay, so NEPDEP stands for the Northeast Pacific Deep Sea Exploration Project. And we decided to make a United Nations Ocean Decade project that stood for everyone working on the deep sea together. So while we come from different agencies, we're all here trying to accomplish the same thing. And so we wanted to create something bigger than all of us. So we work together under this umbrella, and we try better understand the oceans to best protect them for the future generations. And why don't you give them one of the ways to pronounce it? What's the other way of pronouncing it?
Oh, NEPDEP?
Yeah, or?
NEPDEP.
Which one does Charisse like more?
NEPDEP.
Because it sounds like a robot.
Yeah. And also we are in the deep ocean. So that is another thing that I always connect it with.
Absolutely, yeah.
Awesome. I think, did we have a question at the back? Oh, we have a couple of questions. Okay, I'll bring the mic to you. Okay, you want to say your question?
There we go.
Have you guys ever run into like some technical difficulties and like it's really hard to fix them?
Yeah.
Definitely. Yeah, absolutely. I'll hand this over.
Oh, goodness. So electronic equipment doesn't like water. And so it is a struggle every day to send down robots and cameras into the deep sea. In addition to water, they really don't like salt water. So to be honest with you, we've had equipment flood on this expedition, and that happens all the time because we're out here doing frontier research. A lot of the stuff we build by ourselves. So the really great thing is, yeah, things do go wrong. But our team isn't just scientists. We have pilots, technicians. We have workshops on board the ship. We even have 3D printers because when something breaks, we can't just pop out to the hardware store. So it's really important when you're building your science team to have marine spatial planners and scientists. and people on the deck that know how to use power tools, and people that work with electronics that have soldering guns, and people that understand cameras, because we've actually had to rebuild 1 or 2 cameras out on this expedition. So yeah, things go wrong, and you got to make plan A and B and C and D and E and F when you come out to sea. And thank goodness we've worked together, put our equipment back, and we didn't miss a single dive, but it came close a couple times. Yeah. It's a great question because it's real and it happens. Yeah.
Awesome. Yeah, thank you so much. How large is the crew is another question.
There, yeah.
Yeah, so on board the Tully here, we have a total of 42 human beings. So that varies from, we have our Coast Guard crew, which is engineers, people who keep the boat running while we're out at sea. We have our captain and his first and second mates, yeah. And we have our cooks, our chefs that cook for us and keep us really well fed while we're on board. We have it really is a floating city, yeah, and it takes everyone to make it stay afloat and operate really smoothly. So yeah, and we have our row post team, which is six specialized trained people to operate our robot for us, and then the science crew, which was 11, yeah. It's a big
Awesome.
crew.
That's pretty big, yeah. I think we have another question over here.
Great.
Is it true that there is a fish that has human-like teeth?
Oh, Merlin? I just shouted over to our taxonomist, and I think they're Googling it. So we've never met a fish with human-like teeth, but they have lots of different teeth. And with our cameras, we're actually able to get pretty close into their smiles. I actually vaguely remember seeing something about this on BBC, but I can't remember what the answer is. Oh, we actually have somebody from BBC on the boat who's telling me that it was an episode about triggerfish, and we know triggerfish are in the shallows and the tropics. So you are right, but you've managed to stump the scientists on board this ship. So we're gonna have to look that up a little bit. Thank you.
Awesome, thanks. Do we have any other questions? I see 3 more questions. Okay. Right. Okay, we'll ask the kids first. Here you go.
Do you make your electronics and your robots and cameras before you go on the ship, or while you're on it?
Jill, do you want to talk about cameras at all? Do we make the cameras before we come on the ship or afterwards?
Or during.
Yeah. Do you want to answer?
Sure.
Yeah.
So yeah, we do a variety. There's a lot of prep and planning that goes into some of the cameras. Some of the bigger ones, there's teams of engineers ashore that design it, come up with different lenses and shapes and sizes, because that's another aspect of this, is that there isn't a lot of space on the ROV sometimes. So you've got to design these very powerful but compact cameras to go onto these ROVs. And then while we're out here, we might come up with a new idea. So a new challenge that comes up, or we might think of a shot that we want to try to get, which might lead to some innovation and some camera development. So a lot beforehand, and also a lot just out at sea here, coming up with new ideas.
Before you go, who are you?
Sorry. My name is Shelton. I'm here on this expedition from BBC, and I was invited on to come and shoot for the Deep episode that will be coming out on Blue Planet 3 in about 1.5 years from now.
And so there's lots of different types of jobs on the ship. So just pointing out that Charisse mentioned that there's, of those 42 people, there's very diverse jobs, and yours would be one of them.
Yep, absolutely.
Cool, thank you so much. Do we have 2 more questions? Okay. Be quick. Here you go.
Hi, Charisse and Drain. I was just wondering, I know you're sampling both the water column and also the deep sea. I was wondering how important the water column and all what's going on above these deep sea features actually impacts the deep sea environments you see.
Wait, what do you say?
How the pelagic and the surface water.
Is it? Wait, we have people on the boat trying to guess who you are. Do we know you? Or are you just a
Hi,
very...
yeah, it's me, Daniel. Daniel LeBay.
Daniel! Hi. Okay, come in here, you guys. No, water doesn't matter at all. No, I'm joking. I only say that for everyone. Daniel is a NEPDEP team member and studies the water column. So I love this question. As your committee member for your degree, I would say the water is a very important aspect of life, especially on the seamounts. So for those of you who haven't gone to school for a degree in this particular subject, like Daniel, the seamounts act as a ramp that brings up cold, I'm getting nervous because Daniel's listening and he's an expert in this, but like nutrient rich water to the surface, like it ramps up, like you could picture it, because seamounts are a mountain. And then when it gets to the top, it mixes with the oxygen. And what you end up doing is creating the cocktail for life. So you get more animals at the bottom of the food chain that translates into animals further down. And you have these little oases forming around the seamounts. We don't understand everything about the deep sea, and that's why we come out here and we cast these water bottles as deep as 3,000 meters sometimes and collect the water all the way to the surface, because we're really still trying to understand it. While all of this is happening and we're trying to put together the basic pieces, we have also measured that the ocean is changing because of climate change. And so some of the work with our colleagues has shown that these seamounts and the water that bathes them down to 3,000 meters has lost 15% of the oxygen it usually contains in the last 60 years. So that's a really big deal. Can you imagine somebody taking away 15% of your breath? So we're measuring that, we're monitoring that, and we're seeing how that affects the animals that are so long-lived that is a very fast change to them. They're thousands of years old, and they're like, whoa, 60 years, slow down. That's too rapid. And so very important aspect of what we do. And we can't wait to have you back out at sea with us, Daniel. Yeah, that is awesome.
Awesome. That was awesome. Do we have any other questions? Okay, we have one more question. Dun, dun. Here you go.
How big is the blobfish?
How big is the blobfish? Merlin. Hi. How big is a blobfish? I'm getting this size. I'm getting, what is that, 2 feet maybe? Yeah. 2 feet. So the amazing thing is that everything we see, we don't disturb it. We just look at it with a camera. We do send parallel lasers onto the sea floor so we can measure how big things are and get a sense for them. And our special taxonomist on board the ship is telling me yay big, which is about 2 feet. Its eggs were, we actually did suck up some of its eggs. And what would you say, pea size? Smaller than a pea, those little pink eggs that we saw. So while things in the deep sea can be very giant, like the giant squid or the giant copepod, this blobfish is a cute little 2 feet with little pea size eggs. Yeah.
Cherise,
hi.
What's a taxonomist?
What's a taxonomist? A Merlin is the taxonomist. A taxonomist is someone like, and I think this is a great time to pass over to her. On board, we have 2 of them. We have a Merlin and we have a Heidi, and they are the people that get up in the evenings after the ROV comes up on deck and goes through all the animals, because taxonomists study animals. They study how they fit together in the tree of life and how they're related to each other. They collect DNA and make sure that everything we collect goes to the museums. Hey, we have a taxonomist approaching us right now with some little critters. So, Rain, do you mind grabbing a couple of these? And then I think I'll pass it out to our roaming reporter / taxonomist. So taxonomists study the actual animals down in the deep, and sometimes we collect them because they might be the first of their kind. We've actually discovered a lot of species. Is that the blobfish eggs? That is so cool. There you go. There you got it. Perfect. So that jar, and that'll be going to the Royal BC Museum, is thanks to our taxonomists. And if I could use that segue to say, hey, Heidi, can you hear us?
Yes, I can.
You want to go ahead with your roaming reporter?
Sure. Hi, everybody. My name's Heidi, and I wanted to show you that I'm here on the aft or back deck of the John P. Tully. I am just so excited about the past couple of weeks we've had, and you just heard about. We're working together because we study the deep sea. So we go to these really remote places, so they're really far away. So that's why we're on this really huge vessel. And then we're also going deep. We're going deeper than we can hold our breath. We're going deeper than scuba divers can go. So that's why we use tools like the ROV rowboats. But that's also why we're working together in this big team, is because we want to learn from each other, but also because we're creating new knowledge about the deep sea. There was so little that we knew about the deep sea. We're learning so much all the time. And I'm going to show you some of the tools that we use to study them. So I'll just turn my camera around here. So this is what the aft deck of the Tully looks like when we're packing up to go home. It's a busy place. This is one of the tools that we have here. This is called a CTD rosette. So this is what our oceanographers like Daniel use. We send this off into the water column. And if you look closely, you can see that they're just big hollow empty tubes with these cool little blocks down at the bottom. So we send them down like 2,000 meters below the ocean, and then we are able to send a messenger down, and it closes at both the top and the bottom, and it captures that little parcel of water in that deep ocean. So we get a little parcel of water from 2,000 meters, 1,800 meters, that sort of thing. And then what we can do is when we bring it up to the top, we can pull these spouts and we open them up, and water comes out, and we can learn about the chemistry. So like how much oxygen is in the water, and the temperature. And actually we do eDNA analysis, where you look for small pieces of animals or their signatures in the water column to find out what animals are living there. So this is one of our cool tools. But the star of the show is ROV rowboats. Here's some of the fellas working right now. We're all in demo, but we control the ROV rowboats from this ship here. So actually the scientists go up in this little room here, and Charisse will show a picture of what it looks like when they're up in there. It has all the screens that are getting sent up from all the cameras and sensors from the ROV rowboats. And it's actually connected to the ship by this fiber optic cable here that gets sent down by the crane. So we send ROV rowboats over, and it goes up to, well, with us it was only about 2,000 meters, but it can go up to 4,000 meters high into the ocean. And I'm just going to show you for context how big the ROV is. I know a lot of people have followed along online, and you're probably like, oh, what a cute little robot swimming along. Look at how tall it is compared to me. It's so much larger. So I'll show you a few features of rowboats. Now, Charisse and Rain, if my sound gets horrible, will you wave at me? And I'm going to mute myself, and I'm going to point, and you're going to say what I'm pointing at, okay? All right. So first of all, ROV rowboats, our special robot. How it moves around down in the water columns are these things. These are called thrusters. So it has the ability to move forward and backwards. And then it actually has thrusters in the side too, so it can get some side-to-side movements. And then how the pilots control that, they can have spin and go up and down in the water column. This is actually the back of rowboats. I'm going to show you the front in a moment, but I want to show you my favorite thing, because it has a bumper sticker, if you believe it or not. It says, how's my driving? And I brake for sponges. And we're going to actually print them another one that says I brake for octopus, blobfish, and skates, because we tend to stop every single time we see one of those. All right, this is where it might get loud because we're moving on the vessel right now. So Charisse and Rain, are you still able to hear me, or are you hearing waves? Okay, you're still able to hear me. So now we're at the front of the ROV rowboat. Right here is a lens cap for the main camera. This is the main feed of rowboats. And this year we had incredible quality imagery coming out of here. We had different lights and sensors going on here. I honestly can't even tell you about most of them, but what happens is we pick up animals with these cool arms. These is Ropos' arms. They can open this up, it's like a little pincher, and they can pick up things off the sea floor for us. When they pick them up, they put them in these boxes here. These are called bio boxes, and we can bring the animals up to the surface. They can, oh, here's some more cameras that they have. So they have a downward facing one so we can get really discrete pictures of the seafloor. And then some more sampling equipment that we have here is there's a tube that sucks things up. This is called the suction sampler. And that's for smaller things. And it goes up and into this parallel cell here. And we can pull these off. I'm sorry if you can hear the Ropos crew. They're communicating over some loud equipment. And then additionally, we have Niskins to go for the really deep stuff. So same sort of idea, this is unplugged. So I think that hopefully you heard that. I think that's it for RV Ropos. What I'm going to do is I'm going to keep giving you a tour of the vessel while I have my sound off. And for those of you who are curious, we actually kind of live like we're at science camp for adults out here. We have bunk beds. We have a lunchroom where we get to go and hang out and eat, and they feed us, trust me, like 5 meals a day. It's incredible. And I'll just give you a little tour of the vessel. We are in pack-up mode, so it's not perfect anymore, but thank you so much for coming with me on the back. And there goes Robin in to get some more tools. Thanks, team.
Awesome. Thank you, Heidi. Yeah, so I think this is another question opportunity. If you have any questions about Ropos, about the ROV, about life on the ship, anything that that you would like to know more about during our deep sea expeditions.
Do we have any other questions? What about online? Do we have questions in the chat?
Well, I'll just use this opportunity to remind folks that, of course, they can also still use menti.com, and we have a code 35513719. And one of the questions that I see in the chat is, are there lots of sharks out there? Do you know are there sharks? Are you surrounded by sharks? What do you think?
Yes, there are a lot of sharks out here in the pelagic to deep sea areas. We've come across, not so much when our ROV is at its like depth on the seafloor, but we have in the pelagic zone. True. Yes, exactly. So we do see a lot of skates, which are in the same cartilaginous fishes family as sharks. So we are, really excited to see that relative in the deep and thriving in the deep ocean. And the Brev captured some incredible shark footage of, I believe it was bluefin. Yeah, bluefin sharks. So we saw quite a few of those. And then the salmon shark. Yep, that was the photo you saw a little bit earlier.
So it's true. Every creature likes belly rubs. That's what I get from that, is that it doesn't matter what kind of creature you are. If there's a belly rub opportunity, it should be taken.
Absolutely.
Yeah. I have another question here. It's changing direction a little bit, but hopefully it's not affecting you too much. What are your tips for seasickness?
Oh, that's a really good one. I can start. I grew up a little bit more on fishing boats and, not so and smaller boats, not big vessels like the Canadian Coast Guard ship. So my methods proved not effective when I got on this big ship. So when I was on a smaller fishing boat, I would use supplements like ginger to help settle my tummy and just lots of fresh air, and that would do the trick. But out here, sometimes we're confined in a lab for a long time, and it can be rough outside. So being in the fresh air isn't always an option. So what we do take is seasickness medicine, which can come in a variety of forms. One that we seem to like to take is meclizine, and it helps with us stay a little bit more alert while we're working, so we can continue to get our job done while we're also combating that seasickness. Yes.
Hi, everybody. My name is Georgia Clyde. I'm a scientist with Fisheries and Oceans. We have a few other tricks that you can use. So like Rain mentioned, fresh air is great. You can also stare at the horizon. So you can look off into the distance and you can see the edge of the ocean, and that will help ground you when everything is moving on the ship. That's very helpful. Another thing is that you also crave sugary things, and so it's sort of an excuse to be able to eat sugary treats for 3 weeks, and I find that that really does help. Rachel, do you have anything else?
Yeah. First of all, I'm Rachel Lauer. I am a hydrogeologist from the University of Calgary. And I had the same sort of initial, I'll just take Gravol and some ginger. And really, it takes a little bit more than that to get through it. One of the inclinations I have when I get seasick is to not eat, but that can actually make it worse. And we do spend a lot of time looking at screens and focused on something that is moving a little bit, and sometimes just taking a break from that, and as you said, getting outside, looking at the horizon and getting a bit of fresh air helps a lot. Yes. And the beauty is, after a few days, your body kind of gets used to it. Yeah.
Yeah, sorry. I was going to say a good tip for anyone who goes out on boats ever is stand at the back of the ship. It's got the least motion. The front of the ship or the bow of the ship is what hops over the waves, and where the engines are in the back is actually the best. So even if you're on a ferry, like a BC ferry, closer to the back, the better off you are. And I'd say even the people who are seasoned, I like to say I never get seasick. But man, do I get land sick when I get home. When we get back and we close our eyes, especially in the shower, when you wash your hair, you tilt your head back and you close your eyes, that is prime time for falling over. So if it's not seasickness, it's land sickness. So we really love our jobs because we put our bodies through this every chance we get.
I'm with you, Sharice. I'm a land sickness girl myself, but I thought I would also add that about 85% of people get seasickness. So it is the most normal thing to have some seasickness on ship. And it sounds like everybody's ready to help and look after everyone else while you're there. So that's a really great thing about being on that floating community, is that it really is a floating community, which is fantastic. I had another question come in, and again, they're kind of a little bit all over the place, but that's okay. Every question is a valid question, so please don't be shy. But what is the most unusual thing you MacGyvered or used? You were talking about the robots earlier. We had to build something on the fly. What's the most unusual thing you've picked off the ship to become a piece of science equipment?
We wanted to measure the shape of bubbles at cold seeps. And so we basically got a checkers board and we put it in the ROV's hand and we held it behind the bubbles because that black and white pattern gives you something standard to measure against and gives you a nice contrast to see the bubbles. The deep sea is very highly pressurized, though. So I think the scoreboard is 1 for the deep sea, 0 for the checkerboard, because it did get a little bit warped and came up kind of crazy looking. So I do know that our friends at ONC have used a toilet brush to clean cameras before, which sometimes you got to keep it simple. And I'm forgetting the buckets. Please.
Yes, we do use a toilet brush. It's the T-Boss toilet brush of science for cleaning things off. Though checkerboard sounds great. What have you used, Heidi?
Well, actually, it was Sharice's idea. It was her invention. We set up these long-term monitoring sites on a few of the places we've gotten to where we want to come back and measure change over time in the exact same place on a seamount. And so to mark the area, Sharice took bucket lids and put reflective tape on it and tied monkey fists, which are very specific knots so it doesn't fly away, and put a little weight on it and drew big numbers, and we kind of used those as markers. They work surprisingly well. We are here now 6 years later and we are able to see them in the deep sea, and most of them haven't moved except for, say, when octopus steal them to put them near their cave. That did happen. But one thing I wanted to say, when Sharice was talking about the bubbles coming out of the water, it reminded me of something that we've given to Science World that's in the audience with you today that I think you can check out.
So one of the special environments down in the deep sea is something called cold seeps. So this is where methane or gas bubbles out of the sea surface, and it comes out and it looks really weird. It looks like bubbles coming out of the sea floor. But this the chemicals in that interact with the seawater and with bacteria, believe it or not, and they start building up these really cool rocks called carbonate. And sometimes there's even animals living in the carbonate too. And so these create cascading effects for the whole ecosystem. So having hard substrate down there means that like things settle on it and grow, and then fish come and live around those. So you've got one of those rocks in your audience with you today if you want to go find and see something from at least a few hundred meters below the surface of the water. So that just triggered me to remember that.
Yeah, I'll jump in really quickly. We do have the cold sip over there in that table in the corner. So for the audience, if you want to come take a look right now or at the end of the live stream, that'd be great.
If there aren't any other questions, we actually lined up to tell you a couple more things. One, I wanted to show you this screen of screens, because this is what we look at when we're in the control room for the ROV row posts. We see acoustics that come out of the front of the sub so we can detect what's coming at us, like if there's cliffs or rocks. We see cameras in all different directions with gauges. The pilots sit in the front, they control the arms and the cameras. We see main screens like this, really great clarity. This is one of the skates going up the seamount. And so it's really like a NASA control room, where instead of going to outer space, we're going to inner space. So we're exploring within the planet, and it really feels like it's exploration at its most frontier. And then I'm going to hold up the jar, because this is probably the biggest unique finding of our expedition. I'll give it to Rain to talk about it.
Thank you, Charisse. So something that was really, really cool and surprising that we were not expecting to find was on the Tuzo-Wilson seamounts. We explored a new area, and we came across a really, really special and rare coral garden. And this coral is from the precious coral family. So it's very rare. There's a lot of exploration and kind of dredging up for it, because it's used in a lot of jewelry. So, but not only that, it's a really exciting finding, because this will hopefully help us protect this deep sea area and expedite that process, because it's so rare to find in the deep sea, especially a garden full of it.
Perfect.
Charisse, the other day you told us that you found some creatures that are incredibly long-lived, kind of in the neighborhood of the coral. So how long would a coral garden like that take to grow?
Wow. So corals in the deep sea are known to be 4,500 years old at their oldest. So for the audience members out there, these things were building and growing, these individual corals, when the pyramids were being built. So we're talking about long-lived animals. They grow at about 1 centimeter a year. And so the other thing I like to tell people about coral gardens is, if you think about how we should treat old growth forests and how much we care about them and how much they create these forests that other animals can live in and thrive in and eat, and think about that, but now orders of magnitude older, so that the inhabitants of these forests themselves are actually on the order of 100, 200, 300 years old. So just incredibly long lived. And even though this is a small coral, it's an amazing find. For it just to be established may take decades or centuries, because the absolute perfect conditions needed to happen for that little seed of life to settle on the seafloor and take hold there and then start to populate it. And like Rain said, we explored a new part of a volcano. We thought we knew the best story too. We thought, well, how could anything get better than skates laying eggs on an active volcano? This is the stuff Hollywood movies are made out of. And then to find a precious coral that the world deems as globally important and in need of protection just really solidifies One, how amazing the deep sea is and biodiverse, and also the knowledge gaps that exist in the deep sea and in any part of the planet that we don't know as well as we think we should. And it really gives us the warning that, slow down, think things through, because even the best studied seamounts in the deep sea surprise us every time we go down there.
You mentioned the best studied seamounts. How many seamounts are there, and how many are the best studied?
Okay, well, before our expedition started 7 years ago, we thought, isn't Pacific Canada lucky? They have some seamounts in them. And I'm pretty competitive. Rain, you've been to sea with me enough to know this. So I like to say Arctic Canada has no seamounts. These are underwater mountains over 1 kilometer tall. Atlantic Canada, no seamounts. We thought we had 20. Through our expeditions, we've actually mapped 65 and counting. So we're talking about mountain ranges like the Rocky Mountains, just the same slopes, animals, corals that are trees, except instead of bears, sharks, but they exist down there. And just because they're out of sight, because when we look out at the ocean, we see expansive blue. Right below that, these mountains, 65 of them, waiting to be discovered, waiting to be explored. And between them, we've seen on the pictures underwater river-like features, mud volcanoes, rift valleys, canyons, hydrothermal vents, just like Banff Hot Springs, but underwater. There is every bit of complexity that we see on land, but just down there. And so the problem is we kind of gloss over it and we think, the deep sea, it's one place. It's the largest place on our planet. Did you know 95% of animals live in the deep sea? And they communicate with flashing lights, not noise. So that's the majority of our planet. It's as complex, if not more complex, than the land that you and I walk on. And we're just beginning to scratch the surface of understanding what's down there. So I think we've visited 20-something seamounts. So only another 40 to go.
I don't see any more questions in the Menti at this time. How about our live audience? Do we have more questions there?
I don't think we have any other questions.
Alrighty, then maybe I'll put it back to you, Sharice and Rain. Any parting words for us before we go to kind of wrap up, and you guys have to go back to doing the hard work?
Yeah, for sure. I'll start off. I think we're going to have a few other team members join in as well. Hawa, thank you all for joining today and coming to Science World to experience this live outreach event. And we're really excited and happy to share with you what we discovered on this expedition. And hopefully some of you will, grow up and go to school and help us uncover some of these mysteries about the deep sea one day. And we can, to future collaboration. So we're really excited. And I'll pass this off to the next person.
Hi, everybody. Just wanted to say thank you for tuning in and for being interested in the deep sea. We love the work that we do, but to see other people engaged and excited is really just so motivating. And it's an honor to be a part of the science team here. It's an amazing crew that we have. And I just thank you for your inspiration, because it continues to inspire me. So thank you.
Hello, everyone. I'm lucky to be here in many ways. I used to study how groundwater moves on land, and it turns out if you have a nice background in that, you can apply it to the deep ocean. And thinking about how each of these seamounts that we just talked about are actually connected to each other, and honestly, how our oceans are connected to all of us, regardless of where we live, and how important they are to study. So thanks for being here.
Hi, everyone. Thank you so much for joining along with us. We've noticed some people have been watching our streams online and who have been commenting on our social media. And I just wanted to say that reaching the broader audience is a big goal of us with the deep sea because it's so remote. It's so hard to get to that some people kind of forget about it sometimes. And we only protect and care about things we know. So tell your friends, make sure you share with them all the cool things you learned along the way. And I hope to see some of you young people who I heard asking questions in about 5 to 10 years on the vessel.
I think I'll close it up by thanking Science World and Ocean Networks Canada for hosting. I would just say that if you have fallen in love even a little bit with the deep sea through our work, just know that you are so close to the deep sea. It gives you so many great benefits that you probably don't even think about. It's where so much of our seafood comes from. Every second breath you take actually comes from the open ocean. It's where our carbon is stored. It's what gives the stability of our planet the ability to have seasons. It is so close to the life that you love, and you are so close to it. So when you're walking along the streets and you see some plastic, if it goes down a storm drain, it'll probably end up in the deep sea. If you pick it up, you're making a difference. If you choose to eat sustainable food, that's a difference. If you support companies that take environmental awareness to heart, that's you making a difference. And we're at a stage now where our generation is going to have a profound effect on the largest ecosystem on our planet. So I think that we're in a fantastic situation where we actually all can make a difference and feel really good about it. And I think just being in the audience today and listening to us is a part of that change. So thank you so very much. And with that, I will cue my friends to come in here and give you all a big wave goodbye from the 2024 NEPDEP expedition for the very last time. Thank you so very much, everybody. Thank you. Bye.
Thank you so much. Bye.
That's awesome. I'll just share one last thing, if I may, with our audience here. So one last thing for everybody. Here we go. Again, lovely. If you get it, if you'd like to learn more, there's the NEPDEP website. And again, thank you for inviting us today and for coming out. It's really amazing. And of course, we do know that questions pop into your brain at the last minute. Don't be shy. You can email learning@oceannetworks.ca, and I will read them and connect with the people with the answers. So again, don't be shy. Happy to share that with folks. And again, check out that website. I did see one last question pop in at the very last second, which is, when's the next expedition? And the truth is, we don't know. But this is the place to go because it will have updates, it'll have more information, and you can watch and see what's happening as it goes. So I'll stop there and pass it back to my lovely host in the room. And again, thanks everybody for having us. This has been so much fun.
Awesome. Thank